All right, my friends, and again, another example where you're not looking at something that's geometric, so we'll fall back on kind of like the big stick of finding interval of convergence, which is enforcing. So we enforce the condition of convergence of the ratio test. All right, hopefully you're getting kind of the feel for that little sentence there. So now let's get started. We'll have the limit as n approaches infinity of the absolute value of 3x to the n plus 1 over n plus 1 factorial. Now let's divide by a sub n, which is the same as multiplying by its reciprocal. So n factorial over 3x to the n, and we are enforcing its convergence, so we're going to force this to be less than 1. Okay, now let's cancel the heck out of it. So n factorial cancels almost everything out with n plus 1 factorial. So, and then let's see, the 3x's can cancel, n of them cancel out. And then let's see what we've got left now. We've got the limit as n approaches infinity of 3x over n plus 1. Let's factor the constant out front. So as far as the limit is concerned, the absolute value of 3x is a constant. We'd be left with 1 over n plus 1 inside there. And so now let's evaluate the limit. So what's the limit as n goes to infinity of 1 over n plus 1? Oh yeah, it's 0. And so this is a place where a lot of people get stumped, but it's almost helpful, more helpful, if you rewrite it like this, which we usually wouldn't do, right? Because 0 times anything is 0. However, this might help you to kind of see what's going on here. You're looking for the x values that would make this statement true. And I hope it makes sense that it doesn't matter what x is. The left side is going to equal 0. And so you're going to have something less than 1 no matter what x is, which means that there's no restriction on x at all. So the solutions to this statement would be x could be anything from negative infinity to infinity. And what's lovely about this problem is that there's no need to check any endpoints, because how on earth would you check infinity anyway? It's not like all of a sudden you're going to include infinity, right? That makes it look like you don't know what infinity is. So we're done with this one. No need to check in points when you get negative infinity to infinity. So this is your interval of convergence. Where is it centered? Well, truth be told, it could be centered probably pretty much anywhere. I would probably just, to be boring, say it's centered at x equals 0. And what would the radius of convergence be? I would say it's infinity. There you go. All right, my friends, hopefully you feel good about what we're doing here with finding the interval of convergence of a power series. We'll get more practice when we get to AP Prep, but hopefully you feel pretty good about it for now. Take care, everybody.